This is the ECTA, a 300,000-ton tanker vessel built in 1995 to carry oil around the world. It was one of the largest of its kind when it first set sail. The ECTA sailed under several different names and flags throughout its 22 years of service, and in 2017 this massive vessel set out on its final voyage to one of the largest shipbreaking yards in the world. Around 90% of the world's goods are transported by sea, and there are nearly 100,000 large-scale commercial vessels sailing the world's oceans, from oil tankers and cargo ships to fishing vessels and car carriers. Once a ship reaches the end of its operational life, it can be sent to a shipbreaking yard to be broken down and recycled.
We try and track every vessel that ends up at a breaking yard, and what we've seen is that approximately 90% of the tonnage ends up on only 3 beaches in South Asia. So one in India, one in Bangladesh, and one in Pakistan.
The ECTA ended up here, in Chittagong, a port city on the southeastern coast of Bangladesh, home to one of the world's 3 largest shipbreaking yards.
Approximately 600 to 700 vessels are sold to the beaching yards annually. And they usually sell them via scrap dealers that are known as cash buyers, that purchase the vessels cash from the ship owner, often change the flag of the ship, change the crew of the ship, change the registration of the ship, and bring the vessels to one of the 3 beaches in South Asia. These are 12-kilometer long beach stretches with a huge tidal range, and the vessels ramped up during high tide and broken down during low tide. The larger commercial vessels will end up at these beaching yards, and you'll have tankers, cruise ships, military vessels. You'll even have floating platforms. They contain large amounts of steel, which is good to recycle. So they are usually sold and then taken apart for the steel to be used in construction work or in smelting to create new pieces of iron.
Shipbreaking is a largely sustainable industry, but without the proper equipment or enforcement of regulations, the industry can have negative effects on both the workers and the surrounding environment. Ships can contain a number of hazardous materials, such as waste oils, heavy metals, and even asbestos. The safest way to recycle a ship is in a dry dock, where the hazardous materials can be easily contained. But this method is expensive, and there are very few dry docks equipped for shipbreaking. Another method of recycling, which is popular in Turkey and other countries, is the landing or slipway breaking method, where ships are partially landed on shore and broken up from the top down. In this method, the hull of the ship itself prevents toxic materials from entering the environment. The most common method of shipbreaking, though, is beaching. It's the preferred method in India, Bangladesh, and Pakistan. And experts say beaching is where they see the greatest environmental and human impact.
The workers in all 3 countries are internal migrant workers that come from northern regions, poorer regions where there is a lack of employment, and they are often contracted on a daily basis. They work in different facilities. They will lack training. They will need to purchase their own protective equipment in some yards and not have the money to do that. And in Bangladesh, we've seen that approximately 13% of the workforce are underage, so under 18, teenagers. And this is illegal according to also Bangladesh national law, because it's considered a heavy and hazardous industry where under 18 should not be working. But these have been employed and often during night shifts, which is even riskier than working during the day to avoid labor inspectors. It would take everything from 4 to 6 months, maybe longer, to take the vessel apart. There are many causes of accidents at the yard. In the last 6 months, we've been able to document at least 11 workers that have lost their lives at the beaching yards. But we believe that these numbers do not reflect the entire picture. as the fatalities are seldom recorded or made available publicly, the information about the accidents. And it doesn't count, of course, the numerous workers that become sick and die of cancer years after having worked at the yards.
South Asia isn't the only region of the world where ships are recycled. The European Union keeps a list of ship recycling facilities that it's determined meet high safety and environmental standards.
So when the ship arrives in the yard, the first thing we do is the pre-cleaning. So that's removal of all hazardous materials in all the accommodation, wood paneling, furniture, just name it. After that, we got a steel hull. For that, we do all the asbestos removal. Once the asbestos is removed, then we start cutting up of the superstructure, removing of engine rooms, all the engines, all the oars, etc. The remaining hull is pulled on a slipway and is just cut up in smaller pieces with hydraulic pincers and mobile cranes. At the bottom of the slipway, you've got a gully. So would there be anything left inside the hull? It's catch up in the gully and then treated further downwards in the water treatment system. When you start cutting down a ship, you're always bound to be at 2, 3, 4 meters high. So every opening, we got fences all around. All the guys have got falling gear with lifelines and all that sort of thing. So today, all the yards are really anxious to get more vessels in. More than 20 cruise vessels went for recycling the last 6 months, and not one single vessel ended up in Europe.
So with a number of cleaner, safer shipbreaking yards available, why don't ship owners send their vessels to Europe?
Vessels are sold per ton, and in South Asia right now, a ship owner can earn up to $400 per ton, whilst in a more sustainable facility in the US or in Europe, the recycling yard would be able to pay $100 to $150 per ton.
Europe is the biggest net exporter of scrap steel. South Asia is a big net importer of scrap steel, as is Turkey. So the countries that recycle steel do not recycle them because it's a kind of an attractive industry. It is just that they need for the steel primarily. Then they make great use of all second-hand machinery and all kinds of materials. In Europe, you wouldn't use a second-hand pump that's been on a ship for 20 years. In India, they do, and they take the generators and run villages, the electricity for villages. To recycle ships in Europe doesn't make at all economic sense. And the yards that exist in Europe take small ships and take ships that are kind of need to be recycled and cannot travel a long distance.
Despite the poor working conditions in some of the yards of South Asia, the region has seen some improvement. In addition, international legislation such as the Hong Kong Convention for the Safe and Environmentally Sound Recycling of Ships, which was adopted in 2009 but has not yet entered into force, has the potential to dramatically improve standards in yards around the world.
The convention is setting an international set of regulations that govern what materials are allowed on the ship. The convention requires that recycling yards follow certain norms and has requirements for safety, environmental protection, training of workers, emergency response. The major delay is because countries who have significant recycling industries have to be sure the yards that are located in their country are capable of following the requirements. Countries where most of the ships are registered, again, have very little to worry because requirements on ship owners are quite reasonable to follow and reasonable to police. So at the moment, the convention would enter into force if either China or Bangladesh ratifies the convention.
When I started working, I honestly did not think that it would be necessary to still work on this issue 15 years on. But the shipping industry has proven to be extremely conservative and very close to its money. So they are not willing to give up the extra profit they're currently earning on exploiting workers and the environment in South Asia. International waste law forbids the export of hazardous waste from developed to developing countries. And what we're seeing with the shipbreaking yards is a massive disrespect of international law. More companies are adopting sustainable policies. I'm seeing enforcement authorities bringing criminal charges against ship owners that are attempting to circumvent or have circumvented the legislation. And because there is an increased focus on circular economy and green deals. So I do believe that there is a positive future for sustainable recycling at proper facilities.
In 2002, eBay bought PayPal for $1.5 billion, an acquisition that made PayPal's 20-something co-founders very, very wealthy young men. These included people like Peter Thiel, Max Levchin, and Elon Musk. That group and other early investors in PayPal would go on to become known as the PayPal Mafia, using their proceeds from the sale to fund a range of startups and businesses that have become very successful and household names. Out of this group, Elon Musk has been by far the most successful with his creation of SpaceX and electric vehicle company Tesla. So much so that Tesla has now created a mafia of its own, a group of new companies that are emerging in the electric vehicle, battery, and autonomous vehicle space, who could be dubbed the Tesla Mafia.
Tesla had built a reputation that it didn't constrain its actions by what had been done before. And this was tremendously exciting, enticing, and empowering to an engineer to join a company that is both highly mission-driven, but also espouses the notion that there will be fundamental engineering happening that need not be kind of constrained by past ways of doing things.
Tesla reached out to me. It wasn't a job that you apply for. Tesla was attempting to do this project called Model S, and it was led by a gentleman called Elon Musk. And Elon was looking for a new chief engineer. I visited the prototype shop at Tesla where the very first concept of Model S was being constructed. And it was really a Mercedes platform with the roof cut off and a fiberglass top representing what Model S would look like broadly, glooped on. It's death trap on wheels. And I took one look at it and I thought, oh goodness me, this is where they're at. And I was intrigued. Clearly Elon had the provenance, and clearly he had the ambition. And you know, sometimes you think this is a great opportunity in life. This is my chance that I've been waiting for all these years to show what I can really do.
We see 5 particularly interesting individuals who look to be members of this new Tesla Mafia. They include Sterling Anderson, who oversaw development of Tesla's autopilot semi-autonomous drive system when he was at the company. After he left, he went on to co-found Aurora Innovation, which has become a leading developer of self-driving vehicle tech.
Tesla is very good at aligning people around a mission, about setting outrageous goals, about establishing a workplace and an environment where expectations are extraordinarily high, but also constraints are extraordinarily low, which is to say, solve the problem by whatever means you can come up with, despite the fact that it may never have been done before. These were kind of foundational principles that allowed a fertile environment for top flight engineers to do great work. And it's something that myself and other peers who have since left to do their own thing continue to espouse many similar things. In many ways, Tesla is very similar to Aurora on some of these dimensions, right? Strong kind of mission-driven organization, highly talented people, an organization willing to set outrageous goals and aggressively pursue them. And, you know, setting a high bar for employees, not only in terms of kind of their skill, but also in terms of kind of the way they work.
Additionally, there's also Gene Berdichevsky, who was the chief engineer for the battery system for the Roadster, the very first Tesla vehicle that launched in 2008.
We believed in the mission as it stands today. We would get critiqued as, oh, it's just sports cars for rich people, but that was from day one, that wasn't the plan. The goal was always this mass market car, not even the Model 3, but sort of that next car that's coming that's going to be even lower cost. And the plan was there from day one. So we knew the importance that the Roadster played to what we've seen unfold over the last 15 years and what's going to unfold over the next 20. And there were absolutely moments where we didn't think we were going to make it on regular occasions, but I think you built a lot of camaraderie and it was incredibly thrilling. I would drive the only prototype in existence home on the weekends for testing, and it was also really fun to share that and kind of show your friends what the future was going to look like.
Gene has co-founded and leads Sila Nanotechnologies, which is developing advanced materials to make lithium-ion batteries cheaper and more energy dense.
We're competing to make the best battery in the world. We're going to be commercially launching in consumer devices this year. So our technology is ready today. It's not waiting another 5 years to see if it's ready. But at the end of the day, we're also all competing against combustion cars and ending the age of ICE vehicles. So I think we're more allies than we are competitors, but the technology paths we're pursuing are a bit different.
There's also Peter Rawlinson, who was chief engineer for the Tesla Model S. Peter these days is CEO and CTO of Lucid Motors, which is about to launch the Lucid Air, arguably the most advanced electric car ever brought out, and that may even be more compelling in many ways than Tesla's best products.
I hope it's a product that people will really fall in love with, because it is in itself a true labour of love. It's taken many years from a brilliant and dedicated team to create this. Because just like Model S, no one person designs a car. It's too complex. A team designed Model S and a team has designed Lucid Air. A passionate team who are all working to make something really next level. And it has to be. We're up against Mercedes-Benz, damn it. How can we compete? There's only one way. Product is king. Product defines brand.
Tesla's been very effective at creating a whole range of entrepreneurs because the company required a lot of ingenuity and creativity to solve difficult problems to get products out the door as quickly as possible. And that ingenuity turns out to be a common thread among members of the Tesla Mafia. All the companies look to be very well positioned to be significant players and potentially even Tesla competitors in the evolving world of electric vehicles, advanced batteries, and autonomous vehicles.
In theory, there's no reason why Luminar should exist. There's no reason why I or any member of the team should have been able to build what we built. You have some of the largest technology companies and automotive companies on the planet that have been trying to solve this problem for the better part of a decade and beyond. But the fundamental aspect of it is you have to have that strategic vision, that level of innovation, that blank slate approach, and just pure drive, hours, everything that you need to put into it like no tomorrow to be able to successfully deliver and execute. And I think that's the reason why we exist, and that's the reason why some of the greatest technology companies of our generation exist as well. Founded the company about 8, almost 9 years ago with the vision to be able to build a new type of LiDAR sensing system from the ground up to be able to help enable the autonomous vehicle industry. And really had to build something entirely from scratch to meet the very stringent performance requirements, safety requirements, and scalability requirements that were needed to be able to see this industry become a reality. When you have to build something truly from the ground up, everything is a challenge. You know, it's and not a you have to be able to ensure that you're successfully balancing all the different aspects of the business beyond the core technology developments. And to be able to successfully execute on that is something where you're still having to build the plane as it's taking off, and because you have to really have that vision around where you can be. And of course, that if you don't get the technology to work, if you can't solve that risk and that problem, then you're done. It doesn't work. But at the end of the day, it's some motivational driver as well to make sure that you put in everything you got into making sure that it all happens and executes successfully. Building a hardware product that's extremely complex, and in the auto industry specifically, those are three very challenging things that you all have to combine. And at the time, I was like, 16, 17 years old, where I say, hey, imagine this pitch. I have this vision of creating a new type of laser system that will allow cars to be able to drive themselves, and we're going to beat out, like the Googles of this world and all the major automakers at their, development efforts they're going to put into this. Can you invest $1 million? And it's, to be totally frank, the overall venture capital community, even within Silicon Valley, was not exactly super receptive to that kind of thing. It's easy to invest in, easy to understand software technologies. It's very challenging to really wrap your head around the implications of something as complex as this. Of course, equivalently, the rewards are exponentially greater if you successfully deliver on it.
So what you're seeing is basically the raw 3D data in the environment that's being imaged by our LiDAR sensor. So you can see everything going on here in real time. The different colors represent different distances that you can see out in this 120-degree field of view from the LiDAR sensor. This is the eyes of the autonomous car. This is how it can understand what's going on and navigate safely through the environment. And realistically, manual driving being completely obsolete, that's a 2040 problem. What we're solving for is being able to allow it to safely navigate starting on highway scenarios and then expanding the operating domain over time. In addition to being able to enable much safer driving capabilities and active safety systems on the vehicles that are here today.
The physics behind it, how to be able to make all of this work, is really, really hard. And in our case, of course, it always checked out, it always made sense, theoretically. And that's where, after integrating all of these different things, after years worth of work, to be able to have the opportunity to see it, to have it come alive, to have it all work, and now to be powering some of the future of the largest companies in the world in this transportation industry, it is incredibly inspiring, to myself, to the team, to everyone, and what drives us every day. The thing that I'm most proud of is being able to show that we've successfully seen this through, that end to end, and showing that you can have this almost like David versus Goliath scenario in so many different dimensions that can all come together, and it really is possible.
In 2008, a person, or maybe even group of persons unknown, writing under the name Satoshi Nakamoto, wrote the white paper that described the peer-to-peer cryptocurrency we now know as Bitcoin. Fast forward nearly a decade and a half later, cryptocurrencies and the blockchain technology that underlies it not only form the basis of billions of dollars in financial assets, but they're also being used for applications like tracking supply chains or preventing counterfeit goods. But these benefits don't come without a cost. The digital mining process of Bitcoin is very energy intensive, and there's so much computing power being geared towards cryptocurrency right now that the energy use is almost equal to that of small countries like Finland. But cryptocurrency and the process used to mine it doesn't have to harm the environment. There are cryptocurrency protocols now moving towards more efficient, less energy-intensive uses of computing power. And there are other protocols that are actually requiring the use of solar and wind power to digitally mine cryptocurrencies. There are also miners who are producing cryptocurrency by taking advantage of inefficiencies in power generation, which lets them both reduce the impact to the climate while making digital gold. In order to better understand the impact that cryptocurrency and blockchain has on the environment, we talked to two researchers who are studying how digital mining can be made more efficient.
So Bitcoin and productions of other cryptocurrencies and the trading of them over the system can impact the environment through their electricity use, because that electricity that they're using probably isn't emission-free. And when I say emissions, I mean greenhouse gas emissions, of course, CO2, we focus a lot on that. And depending on where that electricity comes from for these mining operations and for these trading operations, it could be more or less carbon intensive.
We hear a lot about methane flares, and usually if you're hearing about methane in the atmosphere, it's just been poured into the atmosphere. A flare means that there is a concentrated enough amount of methane that you can actually burn it. And ideally, you would never release methane into the atmosphere. So flaring is the best thing we can do if there's no other option and there's a very high concentrations of methane. We burn it and turn it all into CO2. Now, the efficiency of that can change quite a lot. So when you see a flare, sometimes they're really burning cleanly, other times they have a lot of black carbon. Ideally, we'll have enough to consume most of the methane, because methane is much worse of a greenhouse gas in the atmosphere than CO2.
We see these types of Bitcoin and blockchain operations wondering how they're going to be part of a net zero future. And they have an opportunity to be a first mover when it comes to moving to zero carbon electricity and really help us to drive the power sector down to net zero.
There are other companies and entrepreneurs looking to reduce the environmental impact of mining cryptocurrency. For example, there's Autonomous, which only uses solar and wind power to mine currency. There are also other companies that only mine currency when there's excess electricity in the power grid, making sure that that produced energy doesn't go to waste. Today, we're going to be talking to Easy Blockchain, which is preventing greenhouse gases from getting into the atmosphere while turning a profit in the process.
When we first were pitching to oil and gas companies, all what we heard was nothing. They were like, what are you guys talking about? Like Bitcoin thing? Like, what is that? Easy Blockchain is a technology company that works with energy companies, helping them to utilize their wasted energy with the help of Bitcoin mining and high density computing. So Easy Blockchain installs mobile data centers to process transactions for Bitcoin mining in the oil fields while capturing wasted gas, which is being burned into the air. My partner has some experience in oil and gas business, and he said, look, there is wasted energy that is in oil and gas sector. There's flared gas. What if we're going to utilize that gas for electricity, and we're going to bring this crypto mining units to the oil and gas producers and use that electricity? So I was like, all right, let me research that. We needed to understand how we're going to capture the gas, what we're actually going to do with that. We put a few small proof of concept for oil and gas customers, and they were very happy. It was working. The demand was so high that we needed to build our own line of manufacturing for mobile data centers to be able to supply enough mobile data centers for oil and gas customers. But then we learned that oil and gas companies, they would want to participate in profit sharing. A big part of this business, of course, is power generation as well. And since we couldn't afford as a small company to purchase power generation assets like gas electric generators and turbines, we had to partner with either generator rental companies or with oil and gas companies themselves, because they usually do have a spare generators on their field. So that's how we were matching their idle assets and wasted energy and our mobile data centers with cryptocurrency mining equipment. So the project in North Dakota right now, the problem we are resolving for one of the producers in North Dakota is that they have 500,000 cubic feet of gas being burned, and because of that they cannot continue their drilling. During the oil production, there is associated gas that comes from the reservoir, and since there is no infrastructure where to put that gas, it has to be burned in order to keep producing oil. Instead of burning natural gas into the air, we use that gas to generate electricity with the help of gas electric generator, And that electricity is being used to run high-density computing in mobile data centers and other applications such as Bitcoin mining. Bitcoin mining, yeah, it uses a lot of power, but hey, we're utilizing that side effect as a tool to do something else and help the environment. And everyone benefits from that because we're reducing CO2 emissions and VOC emissions.
One interesting thing that's being explored by groups like Easy Blockchain is actually using stranded gases. What groups like this are saying is, why don't we take that wasted energy, just being burned and put out into the environment, and why don't we use it to actually produce a good that we want? And so that's the theory there.
Mining cryptocurrency is often criticized for not being worth the environmental harm that it causes. But companies like Easy Blockchain believe that they found a win-win solution that can make mining natural gas a little more green while making green for themselves.
We really went for like the throat of the industry when we first came out at our price point. So there was a really quick adoption, and that's what's allowed us to grow so quickly compared to the rest of the space. I'm Levi Conlow, the co-founder and CEO for Electric E-Bikes, a direct-to-consumer electric bike company based out of Phoenix, Arizona. We came into this space because my old man wanted an electric bike. During college, I had been selling electric skateboards out of my dorm room, and then I had graduated college with my buddy Robbie, and we wanted to work on a business together. And my old man came to us and said, please work on an electric bike. I need you to do that. At that time, the average price of an electric bike was around $3,000. And we knew we could do it for a much more affordable price. And so we start doing the research and we start the sourcing, and went back to the old man and said, great news, man. It's not gonna cost $3,000. It's gonna cost about $40,000. And so he gave us a loan for that first batch of bikes, and it was an absolute disaster. Failed so bad, lost his money, really potentially screwed up his retirement. And we came back to him after the feedback of why people didn't like that first, style of bike and everything. I asked my dad, how would you like to lose $10,000 more? And at that point, he knew I had already screwed up his retirement, so he gave us the extra 10, and then that's what designed the new bike, and then that new bike almost instantly became a massive success. We've only been doing it for about 2.5 years, but it's the fastest growing electric bike company in the US, and we've got over 100,000 bikes sold in the US so far. The reality is, Robbie and I are 25 years old, have the best job in the world selling a ton of electric bikes. So 5 years out, I just want to keep selling more bikes, right? I'm extremely bullish and optimistic on this market, and we just want to keep the good times rolling and just keep riding this journey as long as we can.
In Korea, after college, I worked there 2.5 years in lightbulb company, one of the biggest in Korea. We shipped out lots of merchandise to especially New York metropolitan area. Obviously, 2-3 years later, we have a kind of trouble, quality problem, communication problem. There's no telegram, no text, no nothing those days. So company decided somebody we need to coordinate to stay in USA. So I spent almost 3 years with a Korean company, but it's a hard time with getting money. Korea has no money, so I got money from our import buyer. Meantime, I opened my eye. Oh my God, this is B. Altman, this is Road and Taylor, this is like a USA. Then I decided I can make the dream, something I can make. Then I decided 1971. My own company, which is Bulbrite, was founded.
I often think about what would it be like if I moved to a new country now, where I didn't speak the language, where I couldn't eat the food, like literally couldn't eat the food, and there was no phone, there was no way to communicate with everyone, and I just had to start a new company by myself with my husband in a country that I didn't know. I can't honestly fathom that. I went to college, and then after college, I worked at Pricewaterhouse. I went to school at night to get my MBA. And after that, I went to work for what I thought at the time was my dream job. I was working in Hollywood, working for a producer, but on the business side of things. And the business was moving back to New York. And at the time, the company was about to turn 30. My dad was turning 60, I was turning 30. And he kind of sat me down, having not said anything until that point about, we'd really like you to work in the family business.
It's not the space, it's not the merchandise. We need the manpower, and honestly, I beg her, Kathy, can you help me?
And so it was very subtle, not so subtle. And at that time, I was at a inflection point in my life, turning 30. And I said, you know what, it's kind of now or never. And I would hate for the business to be sold or just not having given it a shot.
She made the final decision. So I say, hallelujah.
He started me in customer service. And I said, why am I starting in customer service? I have my MBA, I can run the financial department, I can do whatever you need me to do. And he said, you have to start with the customers.
The way of business is mechanically, technically, completely earth and sky, like big difference now. But its concept is the same thing. When you work hard, when you good relationship with the customer, that's most important.
I think he thought, okay, she's starting at 30. I'll consider letting her have some more responsibility a decade from now. So at 40, when the business was 40 and he was 70, 2 years earlier than he expected, he did hand over the presidency, and then he became chairman, and then I've been running it since then. I remember sitting with my customer service manager at the time, and she came to my office with a problem. And she said, oh, we have this problem with this customer, what should we do? And I literally leaned in and I said, I have no idea. I just became president yesterday and you've been here for 20 years. What do you think you should do, we should do? And she said, I have no idea. Andrew used to make all the decisions. And I went, wow, this is what the change of leadership, is gonna look like. So I made a very deliberate intent in building a team that was A, smarter than me, and B, empower them to make the decisions. I think that's probably the biggest difference, is the leadership style is different. And it was the appropriate leadership style for that time in the business. And I think this is the right time to, we've grown so much. So if I had to make every micro decision, it would not be fun, A, for me, nor would it be fun for my team.
Once you small dream, you can succeed 110%. Then you got encouragement. Then I figured out this is country. It's really, if you work hard, and you can succeed.
What do I think the American dream is? I agree with him that for me, America stands for the possibilities, right? I think hard work is important, but I think that's only one element of the American dream. I think there's other parts though, and I think part of it is not only what you did for your own family and the families of the people that worked at the company throughout the 50 years, but also what you give back. 9/11 happened right before I joined the company. And I remember thinking to myself, why am I doing this other than it's my family business? And one of the industry leaders at that time, I have the ad up on my wall, said, America needs light, beautiful light, and we're responsible for providing it. And to this day, that is the thing, that's my guiding light. I look at that and go, I now as the leader of this organization that physically makes light, I'm responsible for providing beautiful light, however that manifests itself in this amazing country.
This is the Mekong River in Southeast Asia. It spans over 2,700 miles and passes through 6 countries. And just below the surface of rivers like this lies one of the most important resources on Earth: sand. And we're running out of it. Sand, or aggregate, is a key ingredient in cement. Globally, it's estimated that we mine as much as 50 billion metric tons of sand every year to build our roads, skyscrapers, homes, and more. Rapid urbanization around the world has made sand a high-value commodity, so much so that for some, it's even worth killing for. But not all sand is the same, and experts say some mining operations are damaging ecosystems, infrastructure, and putting people in danger. And hardly anyone is talking about it. Every country on Earth uses sand, and it's mined in a variety of places around the world. It's the most extracted resource on Earth by volume after water, and we've relied on it as a building material since the dawn of human civilization.
Sand is a highly valuable resource, and not only sand in general, but specific types of sand. So sand, chemically speaking, is very crystalline quartz silica sand, and there is a certain particle size that is really required for use in cementitious products like concrete. So we like particles of a certain size. That's really great because it's really angular and it provides a lot of kind of interlocking effects at the microscale level that really contributes to a lot of the strength of the concrete. So a lot of people will think, well, I think there's a lot of sand in the world. Just look at all of the deserts around the world. And actually, it's the wrong type of sand. The sand particles are much, much smaller, and they're actually rounded due to weathering. So if you were to try to make concrete with the sand from the deserts, it's actually quite difficult to do. You need a lot more water to get things flowing, which will actually compromise the ultimate strength of the concrete.
You've got mountains and other, geological formations, and over the thousands and millions of years, they're being eroded by wind and rain, and the elements are constantly chipping away at those giant chunks of stone, breaking off little pieces, grains, right? The rains wash them down the sides of mountains into rivers, and then the rivers carry them from the mountains along across the land and out to the ocean. So all along the way, sand is sort of accumulating at every step along that process. So you have a lot of sand on the bottoms of those rivers, on the banks of those rivers. We mine that sand from basically every one of those places where it occurs. Besides concrete, it's absolutely incredible how many other ways sand touches your life pretty much every single day. We use sand in paint. We use sand in toothpaste. It's used in some wines, every window, every car windshield, the screen on your phone, the silicon chips that run our computers and our phones and every other digital goo god that we use. Those are made from sand too. The elastic band in your underwear is probably made from sand.
While urban expansion has driven an increase in demand for sand around the world, over the past few decades, that demand has especially skyrocketed in the global south, as many developing nations see growing populations and economies.
Makueni County is one of the arid and semi-arid counties in Kenya. So Makueni County borders Nairobi County that hosts the capital city. So it's largely an agricultural community. So basically we rely a lot on agriculture and livestock keeping for our livelihood. All of this is rain-fed with very small pockets of irrigation from the small wells and water pans that collect water during the rainfall. We have only one permanent river, and the rest of the rivers are actually dry riverbeds that are seasonal. Before the devolution, that is the decentralization of governance in Kenya in 2013, we had one central government, and so natural resources were managed from the central government, and sand as a natural resource was largely unregulated. So we've had decades of unregulated and excessive sand harvesting, particularly from the dry riverbeds. It was very easy to transport sand from Makueni and into Nairobi.
The Mekong Delta is an area that is about the size of the Netherlands, about 40,000 square kilometers. It concentrates about 18 million people. It is a food center. It has a much larger contribution to the GDP per unit of area than the rest of the country. And it produces enough rice to feed half of the country. So we're talking about 45 million people, on top of exporting to the world in a wide range from the Philippines to the Middle East. Production of sand is on the main stem of the river across the lower Mekong. So it is not only in Vietnam, it is also in Laos, in Thailand, in Cambodia, and in Vietnam, and probably the highest volumes are extracted in Cambodia.
Despite its status as the second most extracted resource on Earth, there's actually very little regulation, monitoring, or enforcement around sand mining in many countries around the world. As a result, it's difficult for experts to quantify just how much sand we truly extract from the Earth each year. And it makes assessing the scale of the environmental effects of sand mining difficult as well.
So we extract from the earth, we mine the sand that we need in lots of different ways and in lots of different places. Probably the most common and the most problematic way that we mine sand is river sand mining. There's lots of really excellent high quality sand on the bottom of rivers, and it's really easy to get at, right? All you've got to do is send out a big dredge, a big barge out into the middle of that river, drop a pipe down to the bottom of the river and just suck it up like a straw onto your boat. You've got a big boatload of sand, you can take it anywhere you want. And in some places, especially in the developing world, it can be literally just, a few guys with shovels and a pickup truck. At the other end of the extreme, you've got multinational corporations that use huge, enormous dredging ships that can pull up sand from the bottom of the ocean or from the bottom of lakes, hundreds of meters under the water. And in between, you've got, every shape and size you can imagine, from smaller ships to land pits that are dug up using earth-moving equipment. So it really ranges the whole gamut.
There are cascading impacts. If the riverbed itself is dredged for sand, that can make the riverbed deeper, sometimes wider. It changes where and how water flows throughout that system, and where and how sediment flows. As things are removed from the bottom, there's different habitat that is available or no longer available.
We had decades of sand harvesting unregulated, and this led to exposing the dry riverbeds to a lot of degradation. So rivers became dead. Of course, that has an effect on agriculture, so people are not able to produce as much food as they would want.
Naturally, large river systems like the Mekong produced a lot of sediment, about 160 million tons a year. But because of hydropower and higher demand for sand, there's less sediment reaching the sea. There's mainly concession holders who have concession from the government and extract sand. The problem is that the monitoring of the extraction is limited, and it's usually self-monitoring. So we believe that a large part of the over-extraction, if you want, is concession holders who under-report and over-extract. In the lower Mekong, we are probably extracting between 80 to 100 million tons a year. We most probably only have 3 to 5 million tons coming in. It's causing a deepening of the channel. We believe that it's about 2 to 3 meters loss of elevation, so that's significant. You have incision of the riverbed, you have erosion, you have sinking of the deltas. The extraction of sand for construction is done at the cost of significant changes in the ecosystem.
With high demand and little regulation or enforcement, sand mining has become a lucrative business for criminal organizations in some countries. And many are known to work with businesses and builders to supply sand for construction projects, and they aren't above using force to get the sand they want.
Baliram Chauhan was a farmer, a vegetable farmer in a little town about an hour south of New Delhi in India. Huge demand for sand in New Delhi. What happened was this bunch of goons basically came to the village one day, seized about 200 acres of the villagers' land, just took it over by force, ripped up all their crops, stripped out all the topsoil, and started digging up the sand to sell it to developers. Baliram Chauhan was kind of a leader in his village, and he tried to make them stop. He organized protests, he got his fellow villagers together, signed petitions, they went to the courts, they went to the cops, but they could not get anybody to take any action, mainly because there's so much corruption in the system in India, as there is in a lot of the developing world. It's very easy for the sand miners to just spread around a few bribes and people would kind of look the other way. But at a certain point, he was raising enough of a ruckus that it was starting to get under their skin. So at a certain point, these sand miners took him aside and said, look, you're really starting to annoy us. You're bad for business. Cut it out, shut up, or we're going to kill you. But Baliram Chauhan didn't stop. In fact, he reported that threat to the police. 3 days later, somebody burst into his house while he was taking a nap and shot him dead in his own bed. So that kind of violence is happening not only in India, but also in Ghana, in Kenya, in Indonesia, in many parts of the world. It's local activists like Baliram Chauhan, it's journalists who've tried to expose this kind of stuff have been attacked, have been murdered. It's a really, really serious issue.
As the world's urban centers continue to expand, the demand for sand is expected to increase, putting further pressure on the world's rivers, floodplains, and deltas. To meet our demand for sand and mitigate the negative environmental effects of mining it, engineers and scientists are looking at developing more sustainable mining practices and alternative building materials.
So my research team, in collaboration with other researchers at the University of Colorado, recently proved that we can grow a concrete-like alternative. We produced a hybrid living concrete-like building material by leveraging the biomineralization capabilities of photosynthetic microalgae. We took sand and mixed that with a little bit of a hydrogel and inoculated that scaffold with our biomineralizing algae. And what the algae did is that they precipitated calcium carbonate, little limestone minerals that helped cement the entire scaffold structure together. And what we were able to show in our seminal publication is that not only could the bacteria that we use help in manufacturing a concrete-like alternative, we can, under certain conditions, keep the bacteria alive. And we showed that you can actually split this material into two. You can add more sand hydrogel and a little bit of the nutrients that the bacteria like, and two halves became two full bricks. And we did that 2 more times. Our living building material technology can result in materials that have similar compressive strengths to cementitious mortars and concretes that are used today.
While our reliance on sand will remain significant, experts say that the keys to combating the negative effects of sand mining lie not just in sustainable mining practices, but in gathering more data too.
To say that we're running out of sand is true, not in the sense that there will be no more grains of sand and every beach on Earth will be bare rock. That's not going to happen. There's lots of sand left in the world, but much of the sand that's easy to get at is gone. It's tapped out. And so we're having to go further and further and dig deeper and deeper and do more and more harm to get the sand that we need.
There is no silver bullet solution. It's going to take a portfolio of solutions that are tackling this problem from every angle. And the future will include the production of Portland cement, and it will include the production of concrete.
I think there are things that we can do now and in the short term, such as invest more in the monitoring and the understanding of the entire system around sand. And then the policy and the legislation, the requirements, the mandates to think about this issue and use sand more strategically has to catch up with the science and the evolving practices.
The global south still has to continue developing, so we have to make sure that we do not completely stifle the space to develop, but then we must do it in a way that does not harm the environment.
If we are looking to continue to produce concrete and increase our production of concrete, we will need to look to alternative sources of fine aggregate because we know that the earth only has a certain amount.
We all know by now, right? We're burning way too much oil. We're taking too many fish out of the oceans. We're cutting down too many trees. And now come to find out we're running out of sand, right? The most abundant thing on the planet. We consume too much. And by we, I really mean we here in the rich, developed world and everybody in the developing world who's fast catching up to us. We've got to find ways to live our lives and to build our cities that just consume less, not only of sand, but less of everything.
In the 1967 movie The Graduate, the titular character is told that the future can be expressed in just one word: plastics. And that movie wasn't wrong. Advances in chemical manufacturing in the 20th century were able to turn crude oil into products like detergents, industrial chemicals, and yes, plastics. This new type of chemistry drove billions of dollars in economic growth, and it made people's lives infinitely easier. But it didn't come without a cost. Chemical manufacturing is a dirty process that emits fossil fuels, creates its own pollution, and accidents at chemical plants can cause fires and even explosions near city areas. But here in the 21st century, there are companies looking to manufacture chemicals that farmers, manufacturers, and consumers use every day without the dirty process of cracking fossil fuels. These range from genetically modifying microbes to create the chemicals that we need, to even literally creating fertilizer out of thin air. All without the dirty, costly processes that defined chemical manufacturing in the 20th century. To better understand how chemical manufacturing impacts climate change, we talked to two academic experts who've been researching how chemical manufacturing affects the environment and how to make them greener.
The chemical industry is incredibly broad, and in many ways it can kind of be broken down into two major components. The first would be some of the large-scale chemicals that we use. In our industry, we call it commodity chemicals. The other are specialty chemicals.
So most industrial chemicals are part of a petroleum-based supply chain, and we've devised this supply chain and processing paradigm that involves temperature and pressure. So we apply high temperatures or we apply pressure to materials, and that allows them to interconvert and make other chemicals or materials that we need to use. But we know that there are sustainability challenges here. This sort of processing method leads to huge greenhouse gas emissions.
One of the big impacts is energy. A lot of these processes take an awful lot of energy. They're done at high pressure and or high temperature. One of the big negative impacts is all the energy required to make the chemicals generates a lot of carbon dioxide.
What are the prospects for using yeast, bacteria, and other microorganisms to manufacture chemicals?
Yeah, I think nature has this incredible ability to conduct chemical transformations in a really selective manner. And I think learning to harness that capability in an energy efficient manner remains one of the frontiers. And I think we've seen an appreciable amount of progress in terms of being able to take nature's machinery and use it for things that humans desire in a more energy efficient manner.
There are lots of companies and entrepreneurs who are taking the old-fashioned methods of chemical manufacturing and turning them into something that's more efficient, more sustainable, and costs less money. For example, Omaha-based Monolith Materials is taking the greenhouse gas methane and turning it into fertilizer for farms. And today we're going to be talking to Houston-based Solugen, which is taking the waste from corn harvesting and turning it into greener industrial chemicals.
At Solugen, we're using the power of synthetic biology to make low-cost, high-performance, and carbon-negative specialty chemicals. The entire purpose of the chemicals industry is to purchase a low-cost feedstock and convert it into a high-value product as efficiently as possible.
The way we produce our products without the same level of CO2 emissions as the incumbents is by completely reimagining how we think about chemical manufacturing. And the way we do that is we take the best of two worlds. Today, chemistry is made with either petrochemistry or through fermentation. What we've done at Solugen is said, well, we don't want to demonize petrochemistry because it's worked. It's worked for many years. So perhaps there's a way we can marry the two to create something that's better than each.
We take the enzymes from the cells and we take the metal catalyst from thermochemistry and we combine them together in a new way. And for the first time, we can convert feedstock directly into product. So today, we're using corn syrup as our feedstock. In addition to corn syrup, our enzymes and metal catalysts can also convert other sugars, alcohols, as well as vegetable oils into specialty chemicals.
The idea for Solugen actually was born out of our PhD work from me and Sean. One night over a poker game, we started talking and realized that there might be a world where we marry my love for enzymes and biology with his love for process design and metal catalysis to make a more efficient process. Some of the products that we're making for our customers right now are a suite of water treatment chemicals. So these are chemicals that kill bacteria, prevent corrosion of water pipes and tanks, and it prevent hard water from forming in our water supplies.
So after we got the initial $10,000 grant from MIT, we only had $10,000, so the question was, well, we have some customers who are interested in buying our first product. What can we do with this money to deliver on that? So this is a $7,000 essentially PVC bubble column, but with this we were able to make a mixture of hydrogen peroxide and organic acids, but we'd make little 5-gallon buckets, and then I'd put them in my Subaru and drive around Dallas, and those were our first 3 customers were float spas in the Dallas area.
Every aspect of our process technology has been looked at from the lens of sustainability and carbon negativity. It's all 100% wind power here. Today, evaporation is done using natural gas, pretty intense process, but what we've been able to do is use natural gas and actually use one of the world's most energy efficient evaporation technologies that actually allows us to be carbon negative. As a physician, my focus is to do no harm, and now the biggest harm that's happening is what's happening to the environment. And so as a physician, it felt like the only way that I can actually help humanity was to focus on this massive problem. And so that's really what excited us to keep going.
Yeah, what they're doing at Solugen is at the very frontier of making use of an enzymatic toolkit to be able to then produce a commodity chemical in a way that seems very techno-economically and sustainability-wise attractive. And that is, in many cases, felt as though it's out of reach. I think many will be paying a lot of attention to the approach that Solugen is taking and thinking about how to apply that to an even wider range of chemicals.
In the 1960s, the future may have looked like plastics. But in the 2020s, we're taking the biological power of life itself to power a greener and more sustainable way to manufacture the chemicals we need.
So how I have learned about IFF is kind of a funny story, because I was working for 25 years in the pharmaceutical industry, and then somebody reached out to me whether I want to be an independent director on IFF's board. But I had no idea what this company is. I had not even an idea what the industry is. But then I learned so much, and it convinced me that this is a real fun industry. An industry where you get art and science combined. And that's really, really something which attracted me to be on the board of IFF and then later become CEO and chairman.
IFF may not be a company you've heard of, but you've almost certainly used one of their clients' products. We went to their headquarters in New York City to see just exactly how these products are made, and it was pretty mind-blowing.
Yeah, oh yeah. Look, we just do 20% of our business in the US and the rest is international. So we have basically most of our employees somewhere. Asia, probably 20-25%, Europe, probably 30%, 35%, and then Latin America and North America. Look, if you ask me how you get exposed to some of the IFF technologies or products, and you go into a supermarket or in a duty-free shop, I would guess in 1 of 5 or 1 of 6 products, there's certainly an IFF technology. It could be a plant-based burger, which is entirely made of IFF ingredients and technologies. It could be a fragrance you wear, which is a complete IFF creation, where we have invented the molecules, where we have done the creation with our perfumers, and we have manufactured it. So all of that could be exposed to you as a consumer.
Andrew Svig was running Bayer's $12 billion pharmaceutical business for a really long time. And he's taken that kind of pharma CEO energy to IFF, engineered a bunch of really big mergers, including a $26 billion merger with DuPont's nutrition business, which is why now IFF has one of the clearest and strongest platforms to be developing plant-based protein.
We think just broader than flavors and fragrances. We think about total solutions. We think about innovative and very creative spaces to go, like the whole plant-based meat space, where we believe it's good for sustainability, it's good for health. We wanted to be a player there. And they have a couple of other areas, in particular in the biotech field, which were very, very attractive for IFF. So what we have here is a robot, which is basically mixing all these creations to make sure that our customers get the first tests already. Yeah, this is a robot which is doing it all on its own, so you don't need any people. You just put the formula in and it's mixing it automatically. The most fun for me is basically talking to our researchers, talking to our creators about new products. What can we do? What can we invent? And what can we bring to our customers and to the consumers? That's a big fun part. And I can tell you, we have a lot of very, very creative and very knowledgeable employees. And I think we have a very good atmosphere in the company as well. There are a lot of formulas and a lot of things which we test out with consumers and with our customers as well. Here everything is data and facts. And I would say that's something which is very important to me as well. And that might be important about IFF is that we are a company where research and development plays an important role. So we have always a very data-driven approach. The whole aspect of sustainability or ESG is much, much more important these days. And I'm so happy that we started already 7 or 8 years ago to put a real focus behind that. For IFF, it's pretty obvious. We have brought the company from around about 2.9 billion in sales to 11.5 billion in sales. And certainly the market cap has increased quite significantly as well. With that, a lot of changes have happened in the company, but I believe for the better, because the company is now very well positioned to be very successful for the next decade, because we have literally all the ingredients to be successful.
I've been starting businesses since I was 10 years old, and I've always wanted to be an entrepreneur. And so I think the failures is really what led me to being able to start this company and have the success that we've had. My name is John Walsh. I'm the founder and CEO of Indera, and we build electric vehicles. We, at our core, focus on innovating technologies to make electric vehicles cheaper, better than gas vehicles. Since I was young, right, since I was 6 years old, I was always concerned about the environment, and I also was really passionate about business. I watched the movie The Inconvenient Truth in grade school, and it freaked me out, just seeing how, many carbon emissions we're emitting and, potentially creating an unlivable planet. And so, trying to come up with a way, an economically viable approach to a clean energy was really what I found was necessary. I started my first clean tech company when I was 18 in high school. And then I started a water company that also had some, environmental and renewable energy kind of spin to it. And I really realized that, if you want to create a scalable company and if you want to have true impact, you have to make it cheaper and cleaner. And Indera's mission is to end the era of fossil fuels. Finding a way to do it where you're going to have mass adoption has been our core focus. And so making it cheaper, making it better, making it easier, that's what we're here to do. I'm just getting started. And it's been 3 really amazing years of growth, and we want to have thousands of electric vehicles on the road, thousands of employees, because that is truly how we're going to make an impact on our planet and reducing carbon emissions and making a greener world for everybody. So, we're going to be a multi-billion-dollar company, and we're going to save the planet while doing it.
Tesla's having a great year. This month, the electric vehicle maker became the first car maker to hit a $1 trillion valuation. But 15 years ago, it wasn't certain that the company would be where it is today. And the CEO who introduced the company's first roadster in 2006 wouldn't become the face of the company or a billionaire.
Tesla's early days, from its founding in 2003 until about 2006, were an exciting and very volatile time for the company. Its 2 original founders, Martin Eberhard and Mark Tarpenning, had come together with this idea to create an electric sports car because there really was nothing like that on the market at the time.
But around 2004, J.B. Straubel and Elon Musk arrived at Tesla.
They had some funding, but not nearly enough to start something as elaborate and cost and cash intensive as a new auto company. So in 2004, Eberhard and Tarpenning came across Elon Musk, who had recently made a considerable amount of money from the sale of his stake in PayPal. Musk loved the idea for an electric vehicle and agreed to be their principal initial funder, putting the first major investment into the company in 2004.
Musk and Strobel developed a friendship and a common vision about what they wanted to do in the electric vehicle space, and over time, both of them became much more influential in the direction Tesla was taking. Although Eberhard and Tarpenning came up with the original idea and brought on a third engineer, Ian Wright, those three men did not end up becoming billionaires as a result of Tesla's surge in shares over the past year. In large part, that's because Eberhard and Tarpenning's original stakes were diluted significantly.
Over the years, each time the company arranged an additional funding round to raise more capital because making cars is very expensive. With each of those new funding rounds, it further diluted the holdings that Eberhard and Tarpenning had because they were not at the same time investing their own money to maintain their existing stakes. In fact, there were a series of 9 funding rounds for Tesla between 2004 up until its IPO in 2010.
Ian Wright left the company in 2004, even before the public debut of the Roadster electric sports car. Wright has said he did not hold on to any of his Tesla shares, saying he could never imagine the company would end up being worth $1 trillion. And by 2007, Eberhard was forced out as CEO. Tarpenning left a few months later. At the time, both men each held less than 5% in Tesla shares. Strobel, who left Tesla in 2019, is likely to have attained billionaire status from his holdings. His stake may be worth about $1.3 billion, assuming he retains a significant portion of Tesla stock that he held when he left. Strobel declined to comment for this story.
There were a series of other CEOs that were tapped to replace Eberhard, none of whom lasted very long, until Musk himself took control of the company a year later in 2008. Elon Musk was fairly strategic all along. His early money in Tesla brought the company to life. And through each subsequent funding round, he continued to invest more in the company, maintaining the largest stake of any individual investor. The company on November 1st crossed the 1 trillion valuation mark, and no one was a bigger beneficiary of that than Elon Musk. He currently owns approximately 20% of the company, and his stake in Tesla, as well as his investments in SpaceX and his other companies, have increased his net worth to an estimated $300 billion, making him the wealthiest person on the planet. So that early bet that he made on Tesla ultimately paid off far better than he or anyone else could have ever imagined.
The world's oceans make up the largest habitat on the planet, and they contain one of our most vital sources of food, fish, and we eat a lot of it. The average human being consumes around 45 pounds of fish every year, and for over 3 billion people, it's their primary source of protein. Global demand for seafood is rising, fueling a multi-billion-dollar commercial fishing industry. But experts warn that in some places, these commercial vessels are catching more fish than the ocean can provide, threatening sea life and the very people who rely on the ocean the most. According to the United Nations, there are over 370 million indigenous people around the world. Along the world's coastlines, there are more than 27 million indigenous people spread across at least 87 countries. And for many of these coastal communities, the ocean has been vital to their culture and survival for thousands of years.
So coastal indigenous peoples is a group that really encompasses a lot of different types of communities, sometimes entire nations. It's something that's not an official definition. It's something that we use sort of as a shorthand for indigenous communities that still live on coastlines. One defining aspect that we see again and again is an incredibly close relationship with seafood. Just the practice of fishing has a lot of cultural significance, right? So even though Yes, they rely a lot on fish for local food security and nutrition. Even just the practice of going out is a way in which they share stories, communicate knowledge, and really kind of further the traditions.
The Husuk Nation is one of the largest tribes on the Central Coast. We are a marine community. We're located, right, the ocean is right in front of us. We live in a really remote area and it's very isolated and it's very costly to get, groceries up here. So our sustenance and our way of life has been to harvest salmon, spawn on kelp, crabs, prawns, seaweed. Our breadbasket is the ocean.
Typically, a village is a man or woman, but mostly men who go fishing using the traditional canoe and who live mainly on fishing. The village has been there for centuries and they've been transmitting their techniques from generation to generation. This is, for the vessel, I think, the main source of livelihoods and also income for the family. The simplest one we use, the simplest gears, that could be spears or maybe pollen line. While the rich ones can go and buy nets and they will be using those nets. Depending on where they are on the coastline, they can catch like octopus around the reef. Also, they can catch squid, tuna, lobster. Mostly, they are catching small pelagic fish.
Today, coastal indigenous people consume around 15 times more fish than non-indigenous people, and many rely heavily on seafood as a source of income. But in recent years, they've been forced to compete with large-scale commercial fishing vessels capable of catching several tons of fish per day.
Commercial fisheries at industrial scale are relatively recent, right? Obviously, we've been fishing for a long, long time, but when we really see fisheries sort of globally ramp up is, from the 1950s.
British Columbia, home of the world's largest salmon fleets, hits the fisherman's jackpot, a $5 million catch. Nets 1/3 of a mile long are dropped around a school of fish, and the hauling in begins.
There's really two different main kinds. One is the national industrial vessels, right? So a lot of countries have their national commercial fishing fleets, and that often is kind of the first source of conflict, right? You have these larger boats, they're operating locally, but they have much more capacity than indigenous communities have, right? And so that's a big source of competition. Another one that's relatively more recent are distant water fisheries. These are primarily from Eastern Asia, Western Europe. These are fleets that go all over the world, and they have enormous impacts, not only for indigenous peoples, but also for just the countries where they're operating. Probably the most direct way that this is impacted is obviously through overfishing of their shared stocks, but also through crowding out of what used to be traditional indigenous areas. Places where we saw these traditional area-based protections or particular rules about when to fish and how and what. A lot of these commercial vessels don't have any respect for that sort of thing. And so that has caused a lot of conflict and tension.
According to a United Nations report, the marine commercial fishing sector brought in over 186.1 billion pounds of fish and shellfish in 2018. While estimates vary, it's believed that around 1 in every 5 fish sold are caught by vessels engaged in illegal, unreported, and unregulated fishing activity each year.
There's a significant amount of non-compliance out there globally, and not just distant water fleets, just generally throughout the fishing industry. You could have minor offences up to what we call serious infringements. A minor offence could be a mistake on a logbook. Up to a serious infringement, we could be significant fishing over quota, without a licence, without authorization, and those are generally the dark vessels that we talk about, which can do significant damage and harm. Penalties and sanctions for fisheries offences can generally tend to be quite low, and if you're making millions and millions of pounds in illegal fishing, it's worth breaking the law. And there are some organised fisheries crime syndicates that will factor these types of fines into their activity, almost as if it's a business cost.
Many of these vessels use a variety of techniques to skirt the law and avoid detection. but modern technology is helping governments and coastal communities protect their waters from this type of fishing.
So this is done through the use of remote sensing, so satellite technology. We use a varying range of sensors with a different degree of resolution, and they help us to detect vessels that either fish at night by detecting their lights, or fishing during the day, and we can task and focus these satellites in areas of interest. The intelligence and information that comes from that is then given to our partners in government, and they use that to task their patrols and surveillance at sea for fisheries enforcement. One of the problems with vessels on the high seas is that they're technically a piece of that nation's land at sea. Let's just say it's a Madagascar flagged vessel and it's a UK fisheries protection vessel. You would need to get permission from the Madagascan authorities to board that vessel in high seas. And so some of the techniques are a constant changing of flag, which means that you never know which nation you're supposed to be asking permission, or you'll go to one and it turns out they've moved to another, at which point you're running out of fuel, you've got to go, you're hundreds of miles from land. The true dark vessels, the IUU vessels, will use fixers in ports so they can land their illegal catches. We see all sorts. So misreporting of catches. I say I caught it here, and then we've actually seen them fishing somewhere completely differently. We see it a lot on boundaries, a territorial waters boundary, for example, but also on marine protected areas. There are buffer zones around marine protected areas, and you will see a vessel sitting right on the outside of that, pointing in a certain direction that you can be pretty confident that the net is probably inside the area. Often the key thing is they will switch off their tracking system. So this is the AIS, the automatic identification system, or they'll spoof. So they can put another vessel's AIS system on their vessel, or they can actually name themselves something completely different. It's not necessarily that these vessels are not licensed or authorized. And there have been some countries in the past that have made a significant amount of money from opening up their licenses. And so there are various states, flags of convenience they're called, which will open up their licenses and their waters to these vessels without consideration of the smaller communities that rely on the water and the fish.
The reason that a lot of these fisheries, the distant water fisheries, are able to operate far from their home ports is because of government subsidies. These are governments paying for fuel, for bigger boats, for maintenance. So there was one recent study that found that if you took those subsidies away, about 50% of those distant water fleets wouldn't be profitable.
Most countries, if not all countries, subsidize their fisheries in some way. There will be fishing vessels that will be fishing in a non-compliant manner that are in receipt of subsidies.
There are signs of overexploitations. We heard testimony from the Vesu people saying that, once those big vessels are around, there's no more left to fish, and they are forced to go further offshore, which is quite dangerous for the Vesu. The trawlers are destroying the habitats. They are destroying the coral reef, dragging all around and with the fish. It's quite difficult to provide a certain estimate of what they've been losing. What we hear from the elder is that there used to be bigger size of catch in terms of fish, and now it's less and less, and most of the catch today is very small. There's a big impact for the Vesu, especially on the livelihoods and the food security issue.
Some of our elders have talked about going out onto the fishing grounds, that there are so many boats out on the fishing grounds. At nighttime, it looked like a virtual city out on the ocean. Our communities can no longer access salmon as a reliable and abundant food source. We do a lot of our own research here. Our nation has experienced a decline up to 85% in the salmon. And that has had devastating effects, on our community. We attribute this decline to fishing, and that includes sports and recreational. It also includes other human activities as well. And that, includes the effects of climate change. We really feel that, we're, 10, 20 years beyond a crisis.
We reached out to Canada's Department of Fisheries and Oceans for comment on this story. They're aware of the significant decline in salmon along the Central Coast and have launched a $647.1 million effort to stabilize and rebuild stocks. Here's what they said. This initiative includes bold transformative steps like long-term closures of commercial Pacific salmon fisheries and a license buyback program, which will permanently remove fishing effort from Pacific salmon stocks while providing license owners the opportunity to retire with dignity. To continue to build on our understanding of Pacific salmon stocks, a joint technical committee that includes Central Coast First Nations and DFO stock assessment representatives are currently reviewing Central Coast salmon assessments. As coastal Indigenous communities try to combat overfishing, they're also dealing with the issue of climate change, and these two issues are deeply intertwined.
One of the big dangers when you combine overfishing and climate change impacts on coastal Indigenous communities is that, these ways of life will be lost for good. On the one hand, you have these very, very large, very globalized commercial fishing fleets that are just following fish wherever they're moving to. And then you have these habitat impacts of climate change.
We're messing with food chains, we're messing with habitats, we are releasing so much gas into the atmosphere. And now we're starting to see significant impacts on our oceans, we're starting to see reductions in fish stocks.
You get impacts on mangroves, on coral reefs, on sea ice. And those are places where Indigenous peoples disproportionately live around the world. In a lot of places, just because of colonial histories, many of these Indigenous peoples' rights are tied to places. They're even kind of legally, in some ways, bound to the place where they are. And so it's very difficult for them to leave. When people aren't able to fish, they have to move outside of their communities. It doesn't take long for the language to be lost, for the knowledge to be lost. And that is a loss of culture.
It's a part of our DNA. It's a part of who we are. And if we cannot access that, we will lose part of that identity of what we have, which has sustained us since time immemorial.
What the Vejo will do is to adapt themselves on the changing environment. That's why they need support from every stakeholder to ensure that they can keep their activities.
Any of the things that we can do to help starts with granting them more sovereignty over the resources, granting them the power to decide what they're using, how they're using it.
We need to make sure that small-scale fishers, local communities are involved and consulted in big decisions, in high-level decisions regarding fishing agreements or national policy. There is the concept of locally managed marine areas, which is a concept that was developed in the Pacific in the 90s. One of the biggest issues of the LMMA managers in Madagascar is the fact that they are isolated, they are marginalized, they do not have any mean of communication. So that is the reason why those small-scale fishers took the decision to create a national network in 2012.
Currently, it's around 200 and more communities around the islands. This is to help all those communities to join their voice and to be heard.
At that point, they become a legally recognized player in the management table, and that's been something that hasn't happened historically, and it's at the root of a lot of these issues. I do believe that commercial fishing can coexist with traditional Indigenous ways of life, and actually a lot of Indigenous communities are fully engaged with commercial fishing. They're doing it themselves. I think the important thing is that we address the power imbalance that very often is at play between commercial fishing interests and those of Indigenous peoples.
Over the last 20 years, the same advances in technology that have powered the smartphone revolution have also powered changes in the satellite industry. For years, companies relied on truck-sized satellites that cost hundreds of millions of dollars to make. But today, those same satellites can be made orders of magnitude smaller and cheaper. There are satellites orbiting the Earth now that are literally no bigger than a bread box, for those of you who actually know what a bread box is. There are billions of dollars of investment capital being poured into satellites, and that's because they can do lots of useful things. Governments can use them to image natural disasters in order to aid in emergency response. Hedge fund investors can use them to do things like counting cars in parking lots to see what stores are hot this season, or looking at whether oil tankers are moving in and out of refineries to guess oil prices. Law enforcement is even using satellites to track down pirates on the high seas. But this increase in demand for satellites is also driving an increase in demand for rocket launches. After all, the satellites have to get up to space somehow, and we've really only figured out one way to do it. So companies like SpaceX and Rocket Lab have been increasing the number of launches they've been doing every year. And with those increases in launches also comes an increase in pollution. That's because rocket fuels are typically composed of things like methane or kerosene, which produce lots of greenhouse gases. But there are companies looking to improve this process, either by making rocket engines more efficient so that they use less fuel, or by changing the fuels entirely so that they produce less carbon emissions. To understand more about the impact of spaceflight on climate change, we talked to experts in aerospace engineering to learn more about the impact of rockets on climate.
We've been transitioning in the last 10 years away from these kind of giant monolithic spacecraft, one per rocket and a really big rocket to get it out there with government funding, to more of a model of private launch where we have a number of companies that are really kind of competing in the classic capitalist style to try to get a piece of the pie with respect to launching payloads into space.
The propellants, which normally include a fuel and an oxidizer, combine and combust, and then those combustion products are forced out the end of the rocket nozzle to provide thrust and propel the rocket into space.
No matter what the propellant is, the way that you push a rocket off the launch pad and up into the high-speed orbit or escape trajectory that it needs to get away from Earth, you have to push really fast mass out the back of the rocket. And most of it contains some byproducts that contribute to global climate change.
You know, one of the most common fuel combinations is what we call RP1, which stands for rocket propellant 1, which essentially is a high-grade kerosene. Newer rockets are going to methane as a fuel, or liquid natural gas. Liquid natural gas is much cleaner burning. Essentially, you don't have any carbon particles or soot. You still get a little bit of CO2, but it's less than if you're burning kerosene.
A 2018 report from the Aerospace Corporation found that rocket emissions uniquely impact the stratosphere and could potentially affect the ozone layer, although more study is needed. The report recommends that launch companies and scientists do more to understand these impacts before launches get too numerous. There are a lot of companies in the spaceflight industry working to reduce the impact of rockets on the climate. After all, a lot of rocket scientists were inspired by Star Trek, which is maybe the ultimate in a clean energy future. Jeff Bezos' Blue Origin rocket that he used to send William Shatner into space, for example, burned hydrogen and oxygen to output water. There are companies doing other radical sci-fi solutions like Spin Launch, which is building a giant centrifuge in the desert to literally fling satellites into space. Today we're going to be talking with Maine based Blue Shift Aerospace. Its solution is literally more down to earth, using the power of Mother Nature to make a more sustainable, more efficient rocket fuel.
You know, I was born in the early 70s during the Apollo era, and that really set my expectations for what the future would look like and how humanity would be exploring space. Those expectations weren't met for me, and so I ultimately pursued a degree in physics and then later in electrical engineering. But my curiosity for the universe and exploration was always there, and I always wanted to find a way to combine technology and benefiting our planet and humanity. And it wasn't until 2012 that I decided that the time was ripe for a new space company. And I wanted to be the next launch company, and I wanted to do it in a green fashion, in a more Earth-responsible fashion. So here we are, over 240 engine tests later. We've now launched a small prototype version of our green fuel-powered rocket here in Maine. And we're about a year away from launching all the way to space with a commercial payload using a cleaner, nearly carbon neutral fuel for the first time in the world. Our rocket technology is a hybrid rocket, which means the fuel is a solid and the oxidizer, in this case, is a liquid. The fuel is, we believe, close to carbon neutral. Because of the principal ingredient If I could reveal the principal ingredient, which I can't, you would understand that inherently in the creation of the fundamental ingredient, we're capturing a lot of carbon. There's both complexity and advantages to doing a hybrid rocket engine. The benefit is we actually have half the complexity of traditional rocket engines. We also have the advantage that our fuel is inherently very stable. It is non-explosive. It is safer and less complex than traditional liquid fuel rockets, but there's been far less research done around them over the years. And so we decided to start doing a whole series of engine tests using different mixtures and different blends of biofuels. All of them non-toxic, all of them extremely stable, and all of them non-explosive. For the suborbital rocket, we will shoot for 100% reusability. And then for orbital, our plans are to at least recover the first stage, maybe the second stage. It's a very important part of, well, the financial plan is to make them as reusable as possible. So when we launched the rocket on January of this year, it was an incredible experience. I think we were all sort of impressed by how very little exhaust you could see. This is great. Wow, that sound, I love that sound. This is incredible. What I was surprised by was that this small company in Maine that launched a rocket using a bio-derived fuel changed the conversation in about a month after our launch. And since then, I've seen other companies being asked, how are you going to make your launches more renewable? How are you going to make it more earth-friendly? And I think the heat needs to stay on all of us, including our company, and how we can be more sustainable.
Space may be the final frontier for business, but Earth is still the only planet that we can live on. But thanks to companies like Blue Shift Aerospace, we may still be able to reach for the stars without heating up the sky.